Welcome to Op Amp Analysis Problem 1. We'll be looking at an ideal operational amplifier, but we're going to be simulating that in LT Spice and connecting it up as though it was a real op amp. So here you'll notice two power supplies in the schematic. We have V1, it's a 15-volt power supply. Now the operational amplifier needs power, so we're supplying power to it on U1 to its positive power rail. So the positive terminal of V1 goes to the positive terminal of U1. Next on V2 is also a 15-volt source, and the negative side of that is going to the negative power rail on the op amp, the AD795. And this gives us 30 volts across U1. That's 30 volts. So this will supply power to the op amp. And that's all we're doing here. Okay, notice these common connections here on V1. So we've taken two power supplies, two 15-volt power supplies, and we've connected them in series. And where they're connected forms our common connection. So the common of our input V3 here, our 2-volt input source, and the positive input terminal of the op amp are connected together in this way, to common. So now we can solve for the output voltage. So our input is 2 volts. It goes through a 330 ohm resistor. So the ideal op amp rules: number one, the voltage difference between the input terminals is 0. So through R1, it's going to be grounded. That node above R1 is going to be to ground, or common as we've denoted here. So common to the common on Vin and between the two sources, V1 and V2. Also, the current does not enter or leave the input terminal. So if we find the current through R1, the current doesn't go anywhere else. It's not going to go into the input terminal of U1. It's going to have to go through R2. So the current through R1 is going to be 2 volts over 330 ohms, which gives us 6.06 milliamps. Remember, this is an ideal op amp. So ideally, the current is not going to go anywhere else. It's certainly not going to go into the op amp of this ideal op amp. It's going to go up and around R2. In this manner. So the voltage across R2 is going to be 6.06 milliamps times 1,000 ohms, which gives us 6.06 volts. The polarity is reversed here, minus 6.06. So if you were to measure the output between Vout and common, you'd get minus 6.06. We're going to look at the simulation results here in LT Spice, and they're pretty consistent. Now with this particular model, if you increase the input voltage, you'll get a little different result. It's not linear. We're not going to go into that. We're just looking at an ideal op amp model here, and for the purpose of this, it seems to work. So This is the datasheet for the AD795. You can pull this up on Google and take a look at it. You'll see many different curves, op-amp configurations, test configurations. You'll see the pinout. We're going to take the pinout here. I'm going to show you quickly how you would connect this on your breadboard. So we have NC terminals. NC means no connection. So I'm going to put an X there. If you're working on a breadboard, you just don't have to connect those to anything. They're not connected to ground or anything else. Just leave those unconnected. Let's put a power supply in here. I'm going to draw a 30-volt power supply. There are many power supplies that do not have a common. You'll just have a plus and minus terminal. So here we have a 30-volt power supply. You just plug that into your outlet in the wall. So our circuit has a common connection, but the power supply doesn't. So what I'm doing here is putting a voltage divider across the power supply. You're going to want to use large resistors for this. There's really no purpose in drawing a lot of current. Now the positive N goes to your VCC, or plus V. Your negative terminal of the power supply goes here to minus VCC on the chip. Now this is going to be your common lead in the middle of the voltage divider. Common. Let's draw this in blue. There, blue. So I'm not going to connect these, but they must be connected. So they must be connected somehow. If I draw them on the diagram, it's going to get crowded. So this is going to be your input voltage. I'm going to draw a little resistor here. That squiggly is going to be your 330 ohm resistor. Let's connect it kind of how it looks in the diagram. Here's your 1K resistor. Let's bring that over to the output. And that's how you would connect it up on a breadboard. Of course, these two resistors are the same. You want to get an even voltage drop across those. Anyway, thank you for watching. Please check out the next video for a more challenging problem on op amps. Hope to see you there.